Okay, good morning, good afternoon, and good evening to everyone, wherever you're watching me from. Today we are looking at the aspect of linear functions, and I'll try to basically break it down in as we will be solving questions. So this is how basically we're going to move. We'll be solving questions, and then as we are solving questions, we'll be explaining one or two concepts from the yeah. So now, I'm sure I've taught this physically in class, so this is more like a revision lesson. But even someone who has not attended a class is able to get something from just the explanation which I'm going to give in this lesson. So now, number one, here we are looking at functions. I'm sure we understand what a function is. A function, obviously, we are looking at a certain rule assigned. So what is a function? So from the concept of functions, we are simply saying that this is more like a rule. We're talking about a rule assigned, or maybe is a rule that gives or that assigns, a rule that gives, or others will simply say that assigns exactly one output to each input. So that rule which does basically this is basically called a function. So remember, this is just basically a mapping or a relation. So when we talk about the relation where every element in the domain set is basically being mapped to a unique element in the range, that is basically a function. That's what we said. So now in this lesson we're just trying to just grab the aspect of special functions, and one of the special functions which we're trying to talk about here is basically a linear function. So we're now trying to understand a certain special function which we're trying to call a linear function. And what is a linear function? Basically a polynomial of the form f of x equals to mx plus c. That's a linear function. So any polynomial in that basic format, is basically called a linear function. So then what are we trying to say under linear function? We're just trying to bring in understanding that a function whose graph, so a linear function is basically a function whose graph is a straight line. So in short, what we are trying to say is that if I put a linear function on my Cartesian plane, I'll form a certain graph called a straight line. So a straight line is made up from the equation of the line. So we'll have the equation of the line being formed. So from linear functions, we're going to have the equation of the line being formed, which is y equals to mx plus c. So in short, what I have here is basically a standard equation of a straight line in the form, or others will simply call this to be the slope intercept form of the equation of the line. So this is more like our standard form of any equation of the line which you're going to have. So if this is my equation of the line, we can basically describe certain parts or certain important points here. We have this guy m here will be called our slope, c here will be called our y-intercept. So from the equation of the line, there are two important values which you are going to see. You are going to see the value of m and the value of c. The value of m is the slope. The value of c is basically my y-intercept. Y and x are basically two variables which are basically big maps together. Remember, in a function there is input values and there is output values. So the input values are the independent variables here, which are the values of x. The output values are the dependent variables here, which are the values of y. So if y and x are being mapped, with this rule which is being intersecting the two sets, then that kind of a function is called a linear function. So if this is not a rule which is being used, then it cannot be called a linear function. So as long as the rule which connects x and y is this equation, then that kind of rule is called a linear function. That's what we're trying to say here. So x and y are independent, x is independent variable, y is a dependent variable. M and c are basically two real values which we can talk about. Maybe they're just basically constant values. So what is the slope? The slope here we'll be talking about, others will call it to be the gradient. So this is basically our gradient. We can call this even as the gradient. So what is the gradient? We'll be talking about the measure of how steep the line is. Remember, there will be a straight line drawn, and this straight line can be in various forms. So the nature on how this line is steeping is basically called the gradient. And the y-intercept will be the point where this straight line cuts the y-axis. So now let me just briefly talk about the gradient, and then we can start solving the question given to us. So what have I talked about in this? We're simply saying that this equation is the standard form of the equation of the line. So if the standard form of the equation of the line is this, in the standard form, I'm able to locate by default the gradient m and by default the y-intercept without any challenges. So this is what we're trying to say. So now let's try to break it down and look at the same equation of the line itself. So what are we simply saying here? So we have that y equals to mx plus c is my equation of the line. So we're talking about the aspect of the gradient. What is the gradient here? So we're simply saying that the gradient is basically the measure of how steep the line is. So the steepness, so this measure m will be given or calculated by the changes happening in y over the changes happening in x. So that will be my formula which I'm going to be using. So it means that every time I have a change in y over the changes in x, I'm able to measure how my line is basically steeping. So these changes can basically be the second position y2 minus y1 over x2 minus x1. This is in a situation where we have any 2 points. So if I have any 2 points on the line, when this line is sketched on my Cartesian plane, if this is my straight line and moving in that direction sketched on my x or y axis, there can be a point at this particular point and there can be another point there. So if this point is in the coordinates x comma y, and this O point as well is in the coordinates x comma y, we are able to find the gradient. So the gradient is able to be found by the values of x, the changes happening in the y's. So there is a change happening from there to there. There is a change which has basically taken place, and from x to x again there is a change which has taken place. So that is what we're talking about, the second value of y minus the y value, the first value of y, over the second value of x minus the minus the first value of x. So that change will give us the measure of how the line is steeping. So this formula can only work if you have 2 points. So this one is an understanding where we're talking about given any 2 points. So given any 2 points. So the 2 points can be point A in the form of x1 comma y1 and point B in the form of x2 comma y2. So if I have those 2 points, then yeah, that's it. So the given any 2 points, this is point 1 and this is point 2, I'm able to measure my gradient. But if let's say in a situation whereby you've not been given 2 points, what you've just been given is basically the equation of the line. So if this is my equation of the line, from the equation of the line which is in standard form, I'm just be able to pick up my gradient. So if the equation given is basically just y equals to 2x plus c. So in this case, or maybe let's say 2x plus 3. In this case, what do I have? The gradient m will just be equals to 2. As simple as that. And the y-intercept will just be equals to 3. As simple as that. So from the standard equation of the line, I'm able to spot out exactly the value of the gradient and the value for the y-intercept. But in case you don't have the equation, you've been given 2 points, you're able to find your gradient in that manner. So this is just a brief example. So then from there we have to understanding that the understanding you have to have again is that when you are looking at the gradient here being measured in that manner, we're talking about obviously the steepness. So this gradient can be in this form. So m is positive. So if we're simply saying we have 4 cases, if m is positive, then I'm expecting my line to slope in this direction. If m is negative, I'm expecting my line to slope in this direction. If m is 0, I'm expecting my line to be horizontal. A horizontal line, it means the gradient is 0. But if m is undefined, I'm expecting my line to be vertical. So there are 3 cases you have how you're going to see your line. Your line can slope in this direction, from the right, top right, sloping downwards to the left, or from the top left, sloping downwards to the right. So if it is sloping in this direction, I'm expecting a positive gradient. And if it is sloping in this direction, I'm expecting to have a negative gradient. Or if the line is horizontal, I'm expecting the line to be, the gradient to be 0. And if the line is vertical, I'm expecting the line to be undefined. The gradient to be undefined. So those are the 4 cases of your gradient which you are going to experience even as you will be sketching all these kinds of non-can functions. So from this equation of the line, C is basically the y-intercept, the point where the graph cuts the y-axis. So where it is cutting here, there is a value of C. This is what we mean. So where it is cutting the y-axis. So let me just try to delete, then we'll solve this question, because with an understanding of this, we're able to answer question 1 here. So let me just delete, then we can start solving from the first. So we start. In the question here, we are being told that find the slope and the y-intercept if possible. There's even if possible, which means there are the cases whereby a line cannot have a y-intercept. So find the slope and the y-intercept if possible of the equation of the line. These are the equations of the line given. So from the equation of the line, find the slope and the intercept, y-intercept. After I do so, sketch your lines. So the first one, A, we have y equals to -2/5x plus 9. So every time when you want to find the slope and the y-intercept, it should be in standard form, y equals to mx plus c. So compare this to that. The gradient m, or the slope m, is always a constant value attached to the x. So if I compare it with that, what will be my gradient? My gradient will just be equals to, this will be my m and this will be my c. This is my y and this is my x. So we are just comparing the two, so that we can have the gradient to be equals to -2/5 and the value of c, which will be equals to 9, and this will be our y-intercept. As simple as that. So it's just simple when it comes to picking out values. But the question continues. After you've done that, what are you supposed to do? You have to sketch. So it means here I have to sketch my function here, my linear function. I have to sketch it. So how do I sketch it? Sketching a straight line is very simple. It's a very simple sketch you can really think of. So in this case, sketching a straight line, I'm going to just create my table of values. The simple table of values you can create are the intercept form points. So I have x and y values there. So what you can do is, you can say when x is 0 and when y is 0, so that you can basically do your sketch. So here I'm just creating a table of values. So when x is 0, this is basically at the y-intercept. So the y-intercept is the value of y given to me basically when x is 0. So what is going to happen, if I get this 0, insert it in the function, I'll have a certain value of y. That value of y which I'm going to have, that's my y-intercept. So this is called a y-intercept because it is the value of y formed when my value of x is 0. So this is the point you have to understand, that the y-intercept is formed when x is equals to 0, and the x-intercept is found when y is equals to 0. As simple as that. So when x is 0, I'll have the y-intercept. So put 0 in the function here. After the x up, if I put a 0, what am I going to have? I'm going to have y to be equals to negative 2 over 5 multiplied by 0 plus 9. So this will be a 0. So that the y-intercept becomes equals to what? 9. So this will be the value of y will be 9 here. So what will be the coordinates I'm going to use? It will be 0, 9. What about for the x-intercept? The x-intercept works when y is 0. So when I'm solving for x-intercept, finding for the x-intercept, it means when y is 0. So 0 will be equals to negative 2 over 5x plus 9. I'm solving for x. You can take 9 on the other side or take this one on the other side. When take this one on the other side, becomes positive 2 over 5x to be equals to 9. This is the same as saying over 1. When I multiply throughout by a 5 or cross multiply here, depending with the math you know, this will imply that I'm going to have 2x to be equals to 9 by 5, that's 45, over 2 over 2. So the value of x becomes what? So 2 into 4, that's what? That's 2. 2 into 5, that's 2. Remainder 1. So we're talking about 22.5 as the value of x. So those are the coordinates which I'm going to use. So in every equation, I'm able to find the slope and the y-intercept as long as it's in standard form. So the slope and the intercept. The gradient here is negative. How am I expecting my line to slope? I'm expecting to slope in this direction. In this direction. If it was positive, I could have expected to slope in this direction. So those are the differences of the nature of the gradients which I'm going to have. So question A, find the slope. The slope is negative 2 over 5. Find the y-intercept. The y-intercept is 9 from the formula itself. And then after that, sketch. Sketching, create your table of values. Creating my table of values, the simplest we are going to use are the intercepts, and then I'll just connect. It's a straight line. So now, since I have the coordinates, now let me sketch. So how is my sketch going to look like? So I'm going to have my Cartesian plane, x, y. So this is x, o, y. So this can be 0, 9. So 9 can be somewhere there. 0, 9 is at this particular point. 0 in the x-axis, 9 in the y-axis. 25.5, 0. 22.5 in the x-axis. X-axis, maybe 22.5 is somewhere here. 0, 0 in the y-axis will be somewhere there. So the same point number you join. So it means that this will be my straight line, which is going to be formed. So you even label it, say y equals to negative 2 over 5 x plus 9. As simple as that, and you are done. So this is how you've done you do your A. You go to the B part. What is my B part? My B part says 3x minus 2y equals to negative 9. Sure, you'll be able to pause and continue. So let's go to the B part. I'm going to erase. So equation, compare it with a standard form so that you can be able to locate your gradient and your y-intercept. Then you continue. Next we have b 3x minus 2y equals to -9. So it will be very much impossible to grab your gradient m and c here because y is not the subject. So how should your function be in standard form? Compare it in the form of mx plus c. So it means I have to make y the subject. So 3x minus 2y equals to -9. This will be -2y equals to -9. 3x will go the other side, becomes -3x over -2 divided by -2 divided by -2. So the value of y becomes +9 over 2 and +3 over 2x. This is what I'm going to have. So that we rewrite it in this format. Obviously, one of the x starts up, and this becomes y equals to +3 over 2x plus 9 over 2. So from this, what do I have? My gradient m is equals to 3 over 2, and my y-intercept is basically the value of c, isn't it? Is equals to the c value, which is equals to 9 over 2. And you're done. But the next part comes in, you create your table of values so that you can sketch. My table of values, the simplest values I can basically grab are the intercepts values. So when x is 0, the value of y is 9 over 2, which is basically 4.5. And then when x is what? When y is 0, what will be the x? So for the x-intercept. So the x-intercept will be solved as follows. Y equals to 0 to be equals to 3 over 2 x plus 9 over 2, so that I can have this going to the other side becomes -9 over 2 to be equals to 3 over 2x. If I multiply throughout by the reciprocal of that can, so maybe let me just try to break it down from here. So I'm simply saying 0 is equals to 3 over 2x plus 9 over 2. I've just taken it on top, so that when this one goes down there, it's -2 over 2, 3 over 2x. So multiply everything, or maybe because bad manners of cross multiplication, this will be 6x to be equals to -18. So I divide by 6, divide by 6, and the x will be equals to -what? -3. This is what I'm going to have. So it means that the x-intercept here is -3. Then we sketch. So how is my sketch going to look like, So I'm going to have, so I have my gradient, my y-intercept, and my table of values there. This is what I'm going to have. So now let me sketch. How is my sketch going to look like? Let me just delete this part. How is my sketch going to look like? So I'm going to have the y and the x-axis. This is 0. So 0 in the x-axis, comma, y is in 9 over 2, which is 4.5. So 9 over 2 can be somewhere there, which is 4.5. And then -3, this is -3, comma y, which is the same point we're in. So if this point and that point connected, I'm going to have the line which is going to draw in that manner. This is y equals to 3 over 2 x plus 9 over 2. And you're done. So that's basically how I'm going to solve or graph my linear functions. The same. So if you look at how the line has been stepping, it is even obeying the rule that a line which steps in this direction, the gradient should be positive. If the line was stepping in this direction, the gradient would have been negative, and so forth. Let me look at C and D. E and F is yours. You can submit A and F in our M box. So what am I going to have for C and D? Let me delete. So we have that x plus 4 is equals to 0. X plus 4 is equals to 0. So we're trying to put this in the standard form where mx plus a, in the standard form of mx plus a. But in this case, what is happening? It is difficult to look at or to find the value of, I cannot locate the variable y. So what are we simply saying here? Note, if the equation has no y variable, then the line is vertical. Then the line is vertical and has no y-intercept with the gradient undefined. So if the line is vertical, remember we said that if a line is vertical, by default the gradient is undefined. So if the gradient has no y variable in it, if the equation has no y variable in it, then the line is vertical and has no y-intercept with the gradient which is undefined. So here I'm just saying x plus 4. I can't see the y for me to write it in this standard form. So it will be difficult for me to write this in standard form. So this is just basically a vertical line. So x plus 4 equal to 0. This is just basically as good as x equals to negative 4. So sketching this is basically very simple. So if this is your x coordinates, this means that the value of x remains negative 4 for any value of y. So whatever value of y I'm going to have, the value of x will still be negative 4. So it means on my x or y axis I can have negative 4 there. So this is a vertical line passing through at negative 4 on the x axis. It will just be a vertical line passing through at negative 4. So this is x equals to negative 4. We have sketched. Does this have a gradient? The gradient here is basically undefined. Does it have a y-intercept? The y-intercept here, it has no. It doesn't have. Does not have the y-intercept. But the x-intercept is negative 4. So it doesn't have the y-intercept, the gradient is undefined. So any vertical line, the gradient is undefined and has no y-intercept. That is why even from the question it says find the slope and the y-intercept if possible. So the slope is undefined, but the y-intercept is not possible here, it does not have. And the sketch is basically a vertical line passing through at negative 4. So these are the simplest equation you can sketch. The same is happening with D here. D here, I can't see the variable x. So with C, I can't see the variable y, then it's going to be a vertical line. But if I can't see the variable x, then the line which I'm going to have is horizontal. So you can dot that down and look at the concept of D which I'm about to write in the next place here. So what is D? Here we're simply saying that for D we're simply saying that 4y minus 7 to be equals to 0. I can't see the variable x here. So if I make y the subject, I'm going to have 4y to be equals to positive 7 over 4 over 4, and the value of y will be equals to 7 over 4. So what are we simply saying here? If we can't see the variable x, then the equation or the graph, then the graph is a horizontal line. So if it is a horizontal line, what is happening? The slope is 0. That's what it means. So for y equals to 7 over 4, we have m, which is the gradient, to be 0. The y-intercept will still be equals to what? 7/4. So remember, if I try to connect it in the form of y equals to mx plus c, the interpretation here is that if I make y the subject and y is equal to 7/4, it means that this 7/4 somehow can be written as y equals to 0 times x plus 7/4. That is why m is 0 and the value of c is 7/4. So this is my y-intercept, but this is my gradient. And the horizontal line as well is basically simple to sketch because it's just basically direct y equals to that. So on my Cartesian plane, I'm just locating 7/4. 7/4 maybe can be 1 point something, maybe it can be somewhere there, 7/4. So this is just basically the horizontal line passing through at that particular point, and you label it y equals to 7/4. And I always say that every time when you're sketching graphs, do not forget to label your graph. So this is how basically we'll be sketching linear functions. That's how basically we'll be sketching linear functions. So from the concept here, which we already have, what am I saying? We are simply saying that from the equation given, we're able to spot by default the value of the gradient and by default the y-intercept. So you can solve E and F from whatsoever will be explained here. It's the same concept which is going to happen. We are okay. And then I can end by basically looking at this question in this video. So from whatsoever we've discussed so far, then I'm going to end. Just take note down these two questions, submit them in our inbox. So let me just delete and I end with this last question. This question is going to simply say, is saying as follows. So the question is saying that find the slope. Find the slope of the line passing through the pair of points A. The pairs of points for A are 2, 3 and 1, 5. B. The pair of points are 3/4. Sorry, this is -6/7, -2/5, and 3/4, -1/4. So what are we finding here is basically the gradient. So what have I been given is basically any 2 points where the line is passing through. Remember, if it was an equation of the line which has been given, we're able to spot out the gradient from the value of m. But in this case, this is not an equation of the line. This is just basically 2 points which have been given to me to what? To obtain the gradient. So for A, since I have 2 points, remember that the gradient m is basically changes happening in y over changes happening in x. It means this is just as good as what? y2 minus y1 over x2 minus x1. But remember, it is still true if you still start with y1 minus y2 over x1 minus x2. The same as small. It's just basically the changes which should happen. So the coordinates given here are 2, 3 and 1, 5. So from this you can label this as your x1 and this as your y1. This can be your x2 and this as your y2. So that you can have your gradient to be equals to y2 minus y1. This will be 5 minus a 3, x21 minus x21, which is 2. So this becomes 5 minus a 3, 2, 1 minus a 2, -1. So the gradient becomes -2. As simple as that. B, we have the points negative 6, 7, negative 2, 5, and 3 over 4, negative 1 over 4. This is your x1, this is your y1, this is your x2, and this is your y2. So that the gradient becomes y2 minus y1 becomes negative 1 over 4 minus negative 2 over 5, divided by x2 is 3 over 4 minus negative 6 over 7. These are basically just fractions. So what am I going to have? This negative and this will be positive. So this becomes negative 1 over 4 plus 2 over 5 over, this becomes positive, 3 over 4 plus 6 over 7. Pamwamba, if I can even write it in minus, because this is negative 1 over 4 plus 2 over 5 is the same as 2 over 5 minus 1 over 4 over 3 over 4 plus 6 over 7. So what am I doing here? Addition and subtraction of fractions. So that pamuru, what am I going to have pamuru? Lowest common denominator ya pamuru nshinga ni 5 and 4, it's 20. So 4 into 20, it's 4. 5 into 20, it's 4. 4 times 2, it's 8. 4 into 20, it's 5. 5 times negative 1 is negative what? 5. Divided by, which is this line. Or your lowest common denominator between 7 and 4 is what? 7, where 7 and 4 can go into that's 28, huh? Nshinga. 28, I believe. Let me just confirm. But I think 7 back 28, yeah, I think so. So 28 is the lowest common denominator there. 4 into 28, 7. 7 times this, 21. 7 into 28 is 4. 4 times that, it's 4 times 6 is 24. I think so. So that if that is the case, what am I going to have? 8 minus 5 is basically 3 over 20 divided by 21 plus 24. So that's 4 plus 1, that's 5, 45. Let's hope if you can also confirm. 3 divided by 20 equals to that. So this becomes 3 over 20 multiplied by 28 over 45. So that 3 in there, it's 1. 3 in there, it's 115. 2 in there, it's 10. 2 in there, it's 1. 2 in there, it's 19. So this becomes 19 over 150. You can confirm on that one. And yeah, my board looks small, so just deleting this part. So we're simply saying this aspect here, we had 3 over 20 divided by 45 over 28. This is just as good as 3 over 20 multiplied by, because division of fractions, this will change to multiplication, 28 over 45. Then 3 there is 1, 3 there is 15, 2 there is 10, 2 there is 19. I think so. No. 2 in there it's 1, 2 in there it's 16. This is 16, huh? 14. So what? So 14. Again, 2 in there it's 5, 2 in there it's 7. So this becomes 7 over 5 times 15. 5 times 15 becomes what? 5 times 5, that's 25. 5, 6, 7, 75. So this becomes our gradient. If it is not in lowest terms, we can reduce it to lowest terms. So this is how basically we find the gradient given any 2 points. So the submission which you can submit is another pair of points that I'm going to add here is 11 over 2, negative 5 over 3, and negative 3 over 2, negative 1 over 4. You can submit that one as well together with the rest. Thank you very much in this lesson. We'll meet again next time in the next lesson. Thank you and have a blessed night.